Good day. What is Oracle Cloud? Oracle Cloud is a cloud computing service offered by Oracle Corporation providing servers, storage, network applications, and services through a global network of Oracle Corporation managed data centers. So this company allows these services to be provisioned on demand over the internet. Oracle also provides infrastructure as a service, platform as a service, software as a service, and data as a service. These services are used to build, deploy, integrate, and extend applications in the cloud. This platform supports numerous open standards, such as SQL, HTML5, REST, and etc. Open source applications, such as Kubernetes, MySQL, Terraform, and etc., and a variety of programming languages, databases, tools, and frameworks, including Oracle specific, open source, and third party software and systems. Oracle is the database company's public cloud service offering. Oracle has positioned and tailored its cloud services as the best option to run Oracle databases. It is a competitor to the market-leading competitor Amazon. Oracle has a global network of managed data centers set to run their cloud offerings. The company uses Oracle Cloud Services to provide the cloud application servers, storage, and processing on this global network. The network itself is built on 25 gigabyte Ethernet. No node is separated from another node by more than one hop with the network's flat topology. This network gives Oracle the confidence to offer a strong service level agreement. According to Oracle, their later entry into cloud computing enabled them to both learn from the competition's efforts and to better plan their own entry.
The history of the Oracle Cloud. Oracle introduced the Oracle Cloud in 2012, offering the three basics for business, which are the IaaS, or Infrastructure as a Service, PaaS, or the Platform as a Service, and the SaaS, or the Software as a Service, which were already discussed in the earlier parts of the video. Moreover, Oracle ERP Cloud, or the Oracle Enterprise Resource Planning Cloud, was based originally on Oracle Fusion Applications, which is Oracle's enterprise resource planning software suite developed for Oracle Fusion Architecture and Oracle Fusion Middleware, released in 2011. On June 2012, Oracle CTO and Chairman of the Board, Larry Ellison, announced the Oracle ERP Cloud Application Suite as a part of Oracle Cloud, which is the company's broad set of cloud-based applications. Oracle then announced preview availability of Oracle ERP Cloud at Oracle Open World 2012. On October 2015, the company reported that Oracle ERP Cloud had surpassed 1,300 customers. On August 2017, Oracle announced Release 13 of Oracle ERP Cloud. In 2017, Oracle CEO Safra Catz announced the availability of Oracle ERP Cloud in India to assist the country in preparation of its goods and services tax reforms. In September 2017, it was reported Oracle's Cloud ERP business grew 156% in first quarter 2017 to 2018 and had reached an annual run rate of $1.2 billion.
Okay, so now let us talk about the features of Oracle Cloud. First is fully managed with zero administration. So this means that developers do not need to administer data servers or the underlying infrastructure and security. Oracle maintains the hardware and software, which allows developers to focus on building applications. Next feature is faster development life cycle. So, After purchasing access to the service, developers write their applications and then connect to the service using their credentials. Reading and writing data can begin immediately. Oracle performs database management, storage management, high availability and scalability, which helps developers concentrate on delivering high-performance applications. Next is high performance and predictability. Oracle NoSQL Database Cloud Service takes advantage of the latest component technologies in the Oracle Cloud infrastructure by providing high performance at scale. So, developers know that their applications return data with predictable latencies even as their throughput and storage requirements increase. Next, on-demand throughput and storage provisioning. Oracle NoSQL Database Cloud Service scales to meet application throughput performance requirements with low and predictable latency. So, as workloads increase with periodic business fluctuations, applications can increase their provisioned throughput to maintain a consistent user experience, while as workloads decrease, the same applications can reduce their provisioned throughput, resulting in lower operating expenses. The same holds true for storage requirements. Those can be adjusted based on business fluctuations. You can either increase or decrease the storage using the Oracle Cloud Infrastructure Console or the Table Request API. Next, simple APIs. Oracle NoSQL Database Cloud Service provides easy-to-use CRUD or create, read, update, delete APIs, which allows developers to easily create tables and maintain data in them. Next is data modeling. Oracle NoSQL Database Cloud Service supports both schema-based and schema-less modeling. Next is data safety in redundancy. The Oracle NoSQL Database Cloud Service stores data across multiple availability domains or ADs or fault domains known as FDs in a single AD regions. So, if an AD or FD becomes unavailable, user data is still accessible from another AD or FD. Next is data security. Data is encrypted at rest on disk with Advanced Encryption Standard or AES 256. Data is encrypted in motion, transferring data between the application and Oracle NoSQL Database Cloud Service with HTTPS. Next is ACID-compliant transactions. ACID or atomicity, consistency, isolation, durability. Transactions are fully supported for data you store in Oracle NoDatabase SQL service. If required, consistency can be relaxed in favor of lower latency. Next is JSON data support. Oracle NoSQL Database Cloud Service allows developers to query schema-less JSON data by using the familiar SQL syntax. Next, partial JSON updates. Oracle NoSQL Database Cloud Service allows developers to update, meaning they can change, add, and remove parts of a JSON document. Because these updates occur on the server, the need for a read, modify, write cycle is eliminated, which would consume throughput capacity. Next is time to live. Oracle NoSQL Database Cloud Service lets developers set a time frame on table rows after which the row expire automatically and are no longer available. This feature is a critical requirement when capturing sensor data for Internet of Things or IoT services. Next feature is SQL queries. So, Oracle NoSQL Database Cloud Service lets developers access data with SQL queries. Last feature would be secondary indexes. Secondary indexes allows a developer to create an index on any field of a supported data type, thus improving performance over multiple paths for queries using the index.
So for my report, I will tackle about the advantages and disadvantages of Oracle Cloud and as well as the Oracle Cloud application. So first, the advantages of Oracle Cloud. So the compute service. So the Oracle Cloud compute service, it lets you have a provision and manage the compute host known as instances. So you can launch these instances as needed to meet your compute and application requirements. So after you launch an instance, you can access it securely from your computer. You can restart it, attach and detach volumes, and terminate it when you're done with it. So any changes made to the instance local drives are lost when you terminate it, and any saved changes to volumes attached to the instance are retained. So next is the adjustable storage setting. So most of the cloud's operations have different storage capacity, but not all offers or have a features to adjust the storage settings. So and that is the advantage of the Oracle Cloud because you can adjust, like you can increase the storage capacity of your cloud if you have many data to store. Then next is the taking over your network. So the cloud networking products and services, and it allows you to manage and scale your network. So you can connect securely to a customizable isolated virtual cloud network as the heart of your cloud deployment. So it is not that expensive. The data charges allow enterprises to save significant cost while extending their IT environment to the cloud. So the Oracle Cloud Networking technologies provide connectivity solutions across your physical and virtual networks. Next is the assets management. So for the assets management, you can have a full life cycle support. You can manage the entire life cycle of your physical assets to achieve an end-to-end visibility into your maintenance operations. Then you can gain insight into assets. You can track your assets. You can track the streamline processing. Um, so for the assets management, so you can have a full life cycle support, and you can manage the entire life cycle of your physical assets to achieve an end-to-end visibility into your maintenance operation, and you can gain insights into your assets, and you can track your assets. You can have the streamline processing. You can have a drive end-to-end process and the leverage of your internet. Next is the storage service. So the Oracle Cloud infrastructure provides customers with high performance computing and low cost cloud storage options. So through on-demand local, the object files, the Oracle Cloud addresses key storage workload requirements and use cases. So the customers can use the storage gateway and the data transfer service to safely and securely move their data to the cloud. So next is the disadvantages of Oracle Cloud. So we all know that um, the other cloud operations have their disadvantages also. So these are the things that the user or the end user's feedback. So here are the 5 common disadvantages experienced by users. So first is there are no keyboard shortcuts. So this is very inconvenient and time consuming, especially to programmers, because if you have many data to store and you have to do it manually, like to follow the steps in the interface, and like when there is a shortcut that you can easily upload it with the use of keyboard shortcuts. So next is it is visually unappealing. So the interface is very important for the end users because it is the one that they manipulate, and most of the users' feedbacks are the one, or the Oracle Cloud interface is visually unappealing because of the white spaces in it. Next is there are limitations in integrating with other software. So not all other software can be integrated in the Oracle Cloud. Next is it has been mentioned again and again by the users on request to add more tutorials on how to use Oracle Cloud platform. So the users are having a hard time in using the Oracle Cloud because it is not easy to use and navigate. So next is develop other versions that are compatible with other OS. Then next is the advantages certainly outweigh its disadvantages. So if you examine close enough, you'll notice most of the disadvantages are about the user experience. So the architectural and the quality of services are up to industrial standard. So next is the Oracle Cloud applications. So these cloud-based applications are or offer differentiated. So this is also the cloud application. So here are some of Oracle Cloud applications. So to date, they have over 25,000 plus customers around the globe, like Panasonic and etc. So these are the applications. First is the customer experience, human capital management, enterprise resource planning, supply chain management, enterprise performance management, Internet of Things, SaaS analytics and the data, industry solutions, deployment, blockchain cloud service, and the blockchain applications. So basically, these things use the Oracle Cloud to integrate their applications. So it is dependent, or it uses the Oracle Cloud to integrate.
Okay, so now let us talk about the Oracle Cloud infrastructure. But first, let us know what is Oracle Cloud infrastructure. So Oracle Cloud Infrastructure is a set of complementary cloud services that enable you to build and run a wide range of applications and services in a highly available hosted environment. Oracle Cloud Infrastructure offers high-performance compute capabilities as physical hardware instances and storage capacity in a flexible overlay virtual network that is securely accessible from your on-premises network. Next, let us tackle about the services offered by the Oracle Cloud Infrastructure. First service is Analytics Cloud. Analytics Cloud empowers business analysts and consumers with modern AI-powered self-service analytics capabilities for data preparation, visualization, enterprise reporting, augmented analysis, and natural language processing. This empowers leaders, analysts, and IT to access data from wherever they are, including mobile devices. Oracle Analytics Cloud is embedded with machine learning, which helps organizations to discover unique insights faster with automation and intelligence. Next is API Gateway. This enables you to create governed HTTPS interfaces for other services, including Oracle Functions, Oracle Cloud Infrastructure Container Engine for Kubernetes, and Oracle Cloud Infrastructure Registry. API Gateway also provides policy enforcement, such as authentication and rate limiting to HTTPS endpoints. Another service is what we call as application migration. This simplifies the migration of applications from Oracle Cloud Infrastructure Classic to Oracle Cloud Infrastructure. You can use application migration to migrate applications such as Oracle Java Cloud Service, SOA Cloud Service, and Integration Classic applications from Oracle Cloud Infrastructure Classic and Oracle Cloud at Customer to Oracle Cloud Infrastructure. Next is Application Performance Monitoring. This provides a comprehensive set of features to monitor applications and diagnose performance issues. Another is the archive storage. This lets you preserve code data in a cost-effective manner. Archive storage service is ideal for storing data that is seldom accessed but requires long retention periods. This is more cost-efficient than object storage for preserving cold data. Unlike object storage, archive storage data retrieval is not instantaneous. Another service is Audit. This provides visibility into activities related to your Oracle Cloud Infrastructure resources and tenancy. Audit log events can be used for security audits to track usage of and changes to Oracle Cloud Infrastructure resources and to help ensure compliance with standard or regulations. Next is Big Data. This provides enterprise-grade Hadoop as a service with end-to-end security, high performance, and ease of management and upgradability. Oracle Big Data Service provisions fully configured, secure, highly available, and dedicated Hadoop and Spark clusters on demand. Scale the cluster to fit your big data analytics workloads using a range of Oracle Cloud Infrastructure compute shapes, which are supporting small test and development clusters to large production clusters. Another service is the block volume. This provides high-performance network storage capacity that supports a broad range of I/O-intensive workloads. You can use block volumes to expand the storage capacity of your compute instances to provide durable and persistent data storage that can be migrated across compute instances and to host large databases. Next is the Blockchain Platform Cloud. This enables creation of managed, permissioned blockchain networks for secure, real-time data sharing and trusted transactions among business partners. Oracle Blockchain Platform gives you a pre-assembled platform for building and running smart contracts and maintaining a tamper-proof distributed ledger. Oracle Blockchain Platform is a network consisting of validating nodes, which are also called peers, that update the ledger and respond to queries by executing smart contract code, which are the business logic that runs on the blockchain. Next is Cloud Advisor. This finds potential inefficiencies in your tenancy and offers guided solutions that explain how to address them. The recommendations help you maximize cost savings and improve the security of your tenancy. Another is what we call as Cloud Guard. It is a cloud-native service that helps customers monitor, identify, achieve, and maintain a strong security posture on Oracle Cloud. You can use this service to examine your Oracle Cloud Infrastructure resources for security weakness related to configuration, and your Oracle Cloud Infrastructure operators and users for risky activities. Upon detection, CloudGuard can suggest, assist, or take corrective actions based on your configuration. Next is Cloud Shell. Cloud Shell is a free-to-use browser-based terminal accessible from the Oracle Cloud Console that provides access to a Linux shell with pre-authenticated Oracle Cloud Infrastructure CLI and other useful developer tools. You can use the shell to interact with OCI resources, follow labs and tutorials, and quickly run OCI CLI commands. Another is what we called as compute. Compute is used to provision and manage compute instances. You can launch an Oracle bare metal compute resource in minutes. Provision instances as needed to deploy and run your applications just as you would in your on-premises data center. Managed virtual machine or VM instances are also available for workloads that don't require dedicated physical servers or the high performance of bare metal instances. Next is Container Engine for Kubernetes. This helps you define and create Kubernetes clusters to enable the deployment, scaling, and management of containerized applications. This is used when your development team wants to reliably build, deploy, and manage cloud-native applications. You specify the compute resources that your applications require, and Container Engine for Kubernetes provisions them on Oracle Cloud Infrastructure in an existing OCI tenancy. Another is Content and Experience. It is a cloud-based content hub to drive omni-channel content management and accelerate experience delivery. It offers powerful collaboration and workflow management capabilities to streamline the creation and delivery of content and improve customer and employee engagement. Another is what we called as Data Catalog. So this is a collaborative metadata management solution that lets you be more insightful about the data you have in Oracle Cloud and beyond. With Data Catalog, data consumers can easily find, understand, govern, and track Oracle data assets. Up next is the Data Flow Service. It is a fully managed service with a rich user interface to allow developers and data scientists to create, edit, and run Apache Spark applications at any scale without the need for clusters, an operations team, or highly specialized Spark knowledge. As a fully managed service, there is no infrastructure to deploy or manage. It is entirely driven by REST APIs, giving easy integration with applications or workflows. Another is the data integration, which is a fully managed service that helps data engineers and ETL developers with common extract, load, and transform tasks. Tasks such as ingesting data from a variety of data assets, cleansing, transforming, and reshaping that data, and then efficiently loading it to target data assets. Next is DataSafe. DataSafe is a fully integrated cloud service focused on the security of your data. It provides a complete and integrated set of features for protecting sensitive and regulated data in Oracle Cloud databases. Features include security assessment, user assessment, data discovery, data masking, and activity auditing. Another is the data science. Data science is a platform for data scientists to build, train, and manage machine learning models on Oracle Cloud infrastructure using Python and open source machine learning libraries. Teams of data scientists can organize their work and access data and computing resources in his collaborative environment. Another is what we call as data transfer. This lets you migrate large volumes of data to Oracle Cloud infrastructure. Oracle offers offline data transfer solution that let you migrate data to Oracle Cloud infrastructure. You can also export data currently residing Oracle Cloud infrastructure to your data center offline. Moving data over the public internet is not always feasible because of high network costs, unreliable network connectivity, long transfer times, and security concerns. Oracle's transfer solutions address these pain points, are easy to use, and provide faster data upload compared to the over-the-wire data transfer. Next is database. This lets you easily build, scale, and secure Oracle databases with license-included pricing in your Oracle Cloud Infrastructure Cloud. You create databases on DB systems, which are bare metal servers with local NVMe flash storage. You can launch a DB system the same way you do a bare metal instance. You just add some additional configuration parameters. You can then use your existing tools, Recovery Manager, which are RMAN, and the Database CLI to manage your databases in the cloud the same way you manage them on premises. Up next is the Database Management Service. This provides comprehensive data performance diagnostics and management capabilities to monitor and manage Oracle databases. Another is the database migration, which is a fully managed service that helps database administrators move databases in real time at scale from one or more source databases to Oracle Cloud databases. You can configure, run, and monitor database migrations in a single interface. Next is the Digital Assistant. Digital Assistant is a platform that allows you to create and deploy digital assistants. Assistants, which are AI-driven interfaces that help users accomplish a variety of tasks in natural language conversations. Another service is what we call as Edge Services, which encompasses several services that allow you to manage, secure, and maintain your domains and endpoints. Next is email delivery. Email delivery is an email sending service that provides a fast and reliable managed solution for sending high-volume emails that need to reach your recipients. Email delivery provides the tools necessary to send application-generated email for mission-critical communications, such as receipts, fraud detection alerts, multi-factor identity verification, and password resets. Another service of Oracle Cloud is what we call as events. This service helps you to create automation in your tenancy. Oracle Cloud Infrastructure events enable you to create automation based on the state changes of resources throughout your tenancy. You can use the events to allow your development teams to automatically respond when a resource changes its state. Next is the file storage. This allows you to create a scalable, distributed, enterprise-grade network file system. File storage supports NFSv3 with NLM for full POSIX semantics, snapshots capabilities, and data at rest encryption. Up next is the functions. This service helps you build and deploy applications and functions. It is a fully managed, multi-tenant, highly scalable, on-demand, functions as a service platform. It is built on enterprise-grade Oracle Cloud infrastructure and powered by the FN Project open source engine. You can use the Oracle functions, sometimes abbreviated to just functions, when you want to focus on writing code to meet business needs. Next is the Fusion Analytics Warehouse. This empowers you with industry-leading AI-powered self-service analytics capabilities, which are for your data preparation, visualization, enterprise reporting, augmented analysis, and natural language processing. Next is the Golden Gate service, which is a fully managed service that helps data engineers move data in real time at scale from one or more data management systems to Oracle Cloud databases. Design, run, orchestrate, and monitor data replication tasks in a single interface without having to allocate or manage any compute environments. Another is the Oracle integration, which is a fully managed, pre-configured environment where you can integrate your applications, automate processes, gain insight into your business processes, create visual applications, and support B2B integrations. You can use integrations to design, monitor, and manage connections between your applications, selecting from our portfolio of over 60 adapters to connect with Oracle and third-party applications. Another is the Java management, which is a reporting and management infrastructure within Oracle Cloud Infrastructure. It enables you to observe and manage the use of Java in your enterprise. Next is load balancing, which allows you to create a highly available load balancer with your virtual cloud network or VCN so that you can distribute internet traffic to your compute instances within this VCN. The Oracle Cloud Infrastructure Load Balancing Service provides automated traffic distribution from one entry point to multiple servers reachable from your virtual cloud network. The service offers a load balancer with your choice of a public or private IP address and provisioned bandwidth. Next is logging analytics, which is a unified integrated cloud solution that enables users to monitor, aggregate, index, analyze, search, explore, and correlate all log data from their applications and system infrastructure. Oracle Cloud Logging Analytics is a cloud solution in Oracle Cloud Infrastructure that lets you index, enrich, aggregate, explore, search, analyze, correlate, visualize, and monitor all log data from your applications and system infrastructure. Another is the Management Agent, which is a service that provides low latency, interactive communication, and data collection between Oracle Cloud Infrastructure and any other targets. Next is monitoring. So this service is used to query metrics and manage alarms. Metrics and alarms help monitor the health, capacity, and performance of your cloud resources. Another is the MySQL database, which is a fully managed database service that enables organizations to deploy cloud-native applications using the world's most popular open-source database. It is 100% compatible with on-premises MySQL for a seamless transaction to public or hybrid cloud. Leverage your existing Oracle investments and easily integrate MySQL database servers with Oracle technologies. Next is the Network Load Balancer. This lets you set up automated traffic distribution from one entry point to multiple backend servers in your virtual cloud network. Network load balancers ensure that your service remain available by directing traffic only to healthy servers. Next is networking. This is used to create and manage the network components for your cloud resources. You can configure your virtual cloud network with access rules and gateways to support routing of public and private internet traffic. Another is a NoSQL database cloud, which is a high-performance data store which is distributed, shared for horizontal scalability and highly available. It is optimized for applications requiring predictable low latency, such as fraud detection, gaming, and personalized user experience, very high throughput or extreme ingestion rates, such as event processing, IoT, and sensor data. Next is notifications. This is used to set up topics and subscriptions for broadcasting messages. Topics are used with alarms. Up next is the object storage, which provides high throughput storage for unstructured data. Object storage enables near infinite storage capacity for large amounts of analytic data or rich content like images and videos. Block volumes can be backed up to the highly durable object storage for added durability. Another is the Operations Insights, which provides 360-degree insight into the resource utilization and capacity of Oracle autonomous databases. You can easily analyze CPU and storage resources, forecast capacity issues, and proactively identify SQL performance issues across a fleet of autonomous databases. Another is the OS Management Service. OS Management helps you keep operating platforms in your compute instances secure and up-to-date with the latest patches and updates from the respective vendor. Another is the registry, which helps you store, share, and manage development artifacts like Docker images in an Oracle managed registry. Oracle Cloud Infrastructure Registry is an Oracle managed registry that enables you to simplify your development to production workflow. Another is the Resource Manager, which helps you install, configure, and manage resources using the infrastructure as code model. Resource Manager is an Oracle Cloud Infrastructure service that allows you to automate the process of provisioning your Oracle Cloud Infrastructure resources. Another is the Roving Edge Infrastructure, which is a cloud-integrated service that puts fundamental Oracle Cloud Infrastructure services where data is generated and consumed regardless of network connectivity. Roving Edge Infrastructure is the extension of your Oracle Cloud Infrastructure tenancy. Another is the service which we call as Search. This lets you find resources in your tenancy without requiring you to navigate through different services and compartments. Oracle Cloud Infrastructure Search lets you find resources within a tenancy, pages of the console within services, and documentation within the Oracle Cloud Infrastructure Getting Started Guide and Oracle Cloud Infrastructure User Guide. Another is the Security Zones, which lets you be confident that your resources comply with Oracle security principles. If any resource operation violates a security zone policy, then the operation is denied. Next is the Service Connector Hub, which is a cloud message bus platform that lets you connect, that offers a single pane of glass. Which are for describing, executing, and monitoring interactions when moving data between Oracle Cloud Infrastructure services. Another is the Storage Gateway, which is a cloud storage gateway that lets you connect your on-premises applications with Oracle Cloud Infrastructure. Applications that can write data to an NFS target can also write data to the Oracle Cloud Infrastructure Object Storage without requiring application modification to update the REST APIs. Another service is the streaming, which is used to ingest, consume, and process high-volume data streams in real time. The Oracle Cloud Infrastructure Streaming Service provides a fully managed, scalable, and durable solution for ingesting and consuming high-volume data streams in real time. Another is the Support Management Service that allows you to create, view, and manage support tickets. Next is the Tagging Service that lets you use metadata tags to organize and manage the resources in your tenancy. Oracle Cloud Infrastructure Tagging allows you to add metadata to resources, which enables you to define keys and values and associate them with resources. You can use the tags to organize and list resources based on your business needs. Another is the Vault service, which helps you centrally manage the encryption keys that protect your data and the secret credentials that you use for access resources. Vault securely store master encryption keys and secrets that you might otherwise store in configuration files or in code. Another is the vMare solution to create and manage vMare-enabled software-defined data centers or SDDCs in Oracle Cloud infrastructure. An Oracle Cloud vMare solution gives you full access to the features of a vMare SDDC. Next is the vulnerability scanning, which helps you improve your security posture by routinely checking your cloud resources for potential vulnerabilities. This service generates reports with metrics and details about these vulnerabilities. Another is the WAF or Web Application Firewall. By the way, this is the last service that the Oracle Cloud infrastructure offers. So this helps you make your endpoints more secure by monitoring and filtering out potentially malicious traffic. Now let us go to the Oracle Cloud infrastructure's key concepts and terminology. First is the bare metal host. So Oracle Cloud infrastructure provides you control of the physical host, which are also called bare metal machine. Bare metal compute instances run directly on bare metal servers without a hypervisor. When you provision a bare metal compute instance, you maintain sole control of the physical CPU memory and network interface card or NIC. You can configure and utilize the full capabilities of each physical machine as if it were hardware running in your own data center. Next is regions and availability domains. Oracle Cloud infrastructure is physically hosted in regions and availability domains. A region is a localized geographic area and an availability domain is one or more data centers located within a region. Next is the realm. A realm is a logical collection of regions. Realms are isolated from each other and do not share any data. Your tenancy exists in a single realm and has access to the regions that belong to that realm. Oracle Cloud infrastructure currently offers a realm for commercial regions and two realms for government cloud regions, which are FedRAMP authorized and IL5 authorized. Another service is the console. So this is a simple and intuitive web-based user interface you can use to access and manage Oracle Cloud infrastructure. Next is tenancy. When you sign up for Oracle Cloud infrastructure, Oracle creates a tenancy for your company. Tenancy is a secure and isolated partition within Oracle Cloud infrastructure where you can create, organize, and administer your cloud resources. Next is compartments. This allows you to organize and control access to your cloud resources. A compartment is a collection of related resources, such as instances, virtual cloud networks, block volumes that can be accessed only by certain groups that have been given permission by an administrator. A compartment should be thought of as a logical group and not a physical container. Another is what we call as security zones. So a security zone is associated with compartments. When you create and update cloud resources in a security zone, Oracle Cloud infrastructure validates these operations against security zone policies. If any policy is violated, then the operation is denied. Security zones let you be confident that your resources comply with Oracle security principles. Next is the Virtual Cloud Network or VCN, which is a virtual cloud network version of a traditional network including subnets, route tables, and gateways on which your instances run. A cloud network resides within a single region but includes all the region's availability domains. Each subnet you define in the cloud network can either be in a single availability domain or span in all availability domains in the region. Next is instance. So an instance is a compute host running in the cloud. An Oracle Cloud Infrastructure compute instance allows you to utilize hosted physical hardware as opposed to the traditional software-based virtual machines, ensuring a high level of security and performance. Next is image. The image is a template of a virtual hard drive that defines the operating system and other software for an instance. Oracle Linux. When you launch an instance, you can define its characteristics by choosing its image. Oracle provides a set of platform images you can use. Another is shape. So in compute, the shape specifies the number of CPUs and amount of memory allocated to the instance. Oracle Cloud Infrastructure offers shapes to fit various computing requirements. However, in load balancing, the shape determines the load balancer's total pre-provisioned maximum capacity or bandwidth for ingress plus ingress traffic. Available shapes include 100 Mbps, 400 Mbps, and 8000 Mbps. Next is the key pair. So a key pair is an authentication mechanism used by Oracle Cloud Infrastructure. A key pair consists of a private key file and a public key file. You can upload your public key to the Oracle Cloud Infrastructure, and then you can keep the private key securely on your computer. The private key is private to you. It is just like a password. Key pairs can be generated according to different specifications, and Oracle Cloud Infrastructure uses the two types of key pairs for specific purposes. First is the instance SSH key pair. So this key pair is used to establish secure shell or SSH connection to an instance. When you provision an instance, you provide a public key which is saved to the instance's authorized key file. Next is the API signing key pair. This key pair is in PEM format and is used to authenticate you when you submitting API request. Only users who will be accessing Oracle Cloud Infrastructure via the API need this key pair. So next is the block volume, which is a virtual disk that provides persistent block storage space for Oracle Cloud Infrastructure instances. You can use a block volume just as you would as a physical hard drive on your computer, for example, to store data and applications. You can also detach a volume from one instance and attach it to another instance without loss of data. Another is the object storage, which is a storage architecture that allows you to store and manage data as objects. Data files can be of any type and up to 5 to 50 gig in size. Once you upload data to object storage, it can be accessed from anywhere. Another is bucket, which is a logical container used by object storage for storing your data files. A bucket can contain an unlimited number of objects. Lastly is the Oracle Cloud Identifier or OCID. So every Oracle Cloud Infrastructure resource has an Oracle assigned unique ID called an Oracle Cloud Identifier or again OCID. This ID is included as a part of the resource's information in both the console and API.
The Oracle Cloud Engine and Database. The Oracle Cloud Database offers the same benefits that Oracle customers have come to expect from the world-class Oracle databases. But because of its cloud deployment model, the Oracle Cloud Database delivers better agility, faster business operational speed, lower risks, and lower costs when compared to an on-premises database solution. One of the features that makes the Oracle Cloud Database unique is its ability to perform seamlessly in a multi-cloud environment, leveraging the strengths of AWS, Google Cloud, and Microsoft Azure. The database cloud service comes with three main components. The first one is the Application Express, which is a rapid application development and deployment tool that has been proven capable of enterprise-strength application development. The second is a RESTful web service interface, which gives secure access to SQL and PL or SQL through this popular web service standard. And lastly is a collection of applications that can be installed and run with just a few clicks, providing instant business value. The database cloud service is a true multi-tenant offering using schema isolation to secure each tenant's data. This architecture means that the underlying Oracle database instance can use all of its robust resource sharing capabilities for tenants as it does for normal database users. However, the nature of the database cloud service means that you will not be able to simply move an existing Oracle database from your own instance to the database cloud without some migration effort. Since the database cloud service does not support SQL NAT access from outside the Oracle Cloud, you would either have to A. Run an existing Java application in the Oracle Java Cloud, B. Run an existing Application Express application in the database cloud, or C. Replace existing SQL access calls with RESTful web services for data and logic access instead of standard SQL over SQLnet. This depends on the architecture of your application, though the migration effort required for this transformation might be significant. In some cases, you may decide that you could save time by simply developing a new version of your application for the database cloud service, secure in the knowledge that you could move the application and database to other cloud and in-house platforms if you wish. What's the top Oracle Cloud database? So the Oracle Cloud databases come in two options. First is the Oracle Autonomous Database Cloud and the Oracle DBaaS. The Oracle Autonomous Database Cloud is the world's first self-driving, self-securing, and self-repairing database. Though your team maintains full control and responsibility for managing your database with Oracle Autonomous Database Cloud, the Autonomous Database does a lot of work for you by leveraging advanced machine learning systems to apply updates and patches, tune your database automatically, and simply the provision process. So the Oracle Autonomous Database Cloud is self-driving, which means it automates database and infrastructure management, monitoring, and tuning. It is also self-securing, which means it protects from both external attacks and malicious internal users. And self-repairing, which means it protects from all downtime, including planned maintenance. Next is the Oracle DBaaS, or the Oracle Database as a Service. This is a managed cloud database available as a fee-based subscription that can significantly lower your CapEx, or CapEx meaning capital expenditure. Since the database is provided as a service, Your enterprise can choose to have various database management and administration activities performed for you. Uh, the typical the database is typically stored on your managed services provider's infrastructure and is a good option for those companies wishing to outsource their database administration tasks. So this is the database cloud service pricing. You have a 30-day free trial which offers a 1 schema, an Oracle database 11G release 2, and a 1 gigabyte of disk storage, and a 6 gigabyte of data transfer. Database S5 costs $175 per month, uh, which also offers 1 schema, but 5 gigabyte of disk storage and 30 gigabyte data transfer. Database S20 additionally costs $900 per month, which also has 1 schema, the same Oracle Database 11G Release 2, but it has 20 gigabyte of disk storage and supports 120 gigabyte of data transfer. And the database S50 costs $2,000 per month, the same 1 schema, but 50 gigabyte of disk storage and 300 gigabyte data transfer.
The Oracle Cloud Deployment. Oracle Cloud is available in 25 regions as of September 2020, including North America, South America, UK, European Union, Middle East, India, Australia, Korea, and Japan. You can deploy your projects, build artifacts to Oracle Java Cloud Service, to Oracle Application Container Cloud Service, and to Oracle Java Cloud Service SaaS extension from Oracle Developer Cloud Service without leaving its web interface. Oracle Cloud is available as a public cloud Oracle managed regions to select government agencies as an Oracle managed government cloud in the United States with FedRAMP High and DESA IL5 compliance in the United Kingdom. And as a private cloud or hybrid cloud as an Oracle managed database only service or full service dedicated region, what Oracle calls cloud at customer. The recommended way to deploy build artifacts to GCS and ACCS is to do so in a build step. You still need to use a deployment configuration to deploy build artifacts to GCS-SX. See Deploy Build Artifacts to Oracle Cloud Services for information about using a build step to deploy applications. Here are some concepts and terms that this documentation uses to describe deployment functions and components in DevCS. First term is deployment configuration. It defines how to deploy a build artifact to a target Oracle Cloud service. Second term is deployment target, an instance of the target Oracle Cloud service. And last term is the continuous delivery, a method to automatically deploy a build artifact to the target service. So deploy an application to Oracle Java Cloud Service. You can deploy your application to a publicly available GCS instance and make it publicly accessible. You can deploy your application from DevCS to GCS using the Oracle WebLogic RESTful Management Interface or the SSH panel. You can use either the RESTful interface or SSH to deploy to the Oracle WebLogic server 12C of GCS, but you can only use SSH to deploy to Oracle WebLogic server 11 grams 10.3.x of GCS. Before creating a deployment, enable the HTTPS or the SSH access rule in the GCS console.
Use the Oracle WebLogic RESTful Management Interface. Deploying to GCS using the Oracle WebLogic RESTful Management Interface is easy and doesn't require any additional configuration. Here are the steps in deploying the GCS using the Oracle WebLogic RESTful Management Interface. First step is in the navigation bar, click Deployments. Second step is click Create Configuration. Third is in Configuration Name, enter a name to identify the deployment configuration. By default, the same name is used by application name. However, you can modify it. Fourth, from the deployment target drop-down list, select the GCS target that uses the Oracle WebLogic RESTful Management Interface. To create a target, add an Oracle Java Cloud Service deployment target. Fifth, to deploy the artifact manually, from the type options, select On Demand. To deploy the artifact automatically every time the specified job's build is successful, select Automatic. Sixth, in Job Build an artifact, specify the job build an artifact to deploy the target service. Build isn't available if you selected Automatic as type. If you selected On Demand as type, click Save and Deploy. If you selected Automatic as type, click Save. Use SSH. To deploy to a GCS instance using SSH, you must set up an authenticated connection between DevCS and GCS. To set up the connection, get the DevCS SSH public key and append it to the authorized keys file of the GCS instance. Then, create a deployment configuration to deploy the artifact. Upload the DevCS public key to the GCS instance. This is a one-time step. After a connection is authenticated, you don't have to repeat the steps to upload the public key. So here are the steps. First, get the DevCS SSH public key through the REST API. Use this URL syntax to get the key. If the base URL of your DevCS instance is https://developer.us2.oraclecloud.com/myorg, then your host name is developer.us2.oraclecloud.com and the organization name is my-org. Don't enter the URL in the web browser address bar. Instead, use CURL or a browser REST plugin to set the SSH key. For more information about CURL, see http://curl.hacks.se. So here is the example of a CURL. Use the same username and the password you use to access DevCS. When you have the key, copy the key string value and save it in a pub file. For example, odcskey.pub. Second step, in the GCS console, open the overview page of the service instance. And to know more about the overview page, see Exploring the Oracle Java Cloud Service Instance Overview page in Administering Oracle Java Cloud Service. Third, in the header of the overview page, click next to the Oracle Java Cloud Service link and select SSH Access. Fourth, in the Add New Key dialog box with Upload a new SSH public key value from file selected, click Browse and select the DevCS SSH public key file that you saved in step 1. You can also copy the key value to the key value text box. Fifth, click Add New Key. Sixth, in the Add New Key dialog box, click Submit. The DevCS SSH public key is added to the authorized keys file of the GCS instance. After adding the public key, the instance restarts automatically. Wait for some time. The icon in the header section also changes. You can track the restart activity in the activity summary section of the overview page. When the instance has restarted and the activity is complete, you see the Add SSH Keys Completed message in Activity Summary. Next is create the deployment configuration. See, here are the steps for creating the deployment configuration. First step is open DevCS. The next, in the navigation bar, click Deployments. Third, click Create Configuration. Fourth, in configuration name, enter a name to identify the deployment configuration. By default, the same name is used by application name, however, you can modify it. Fifth, from the deployment target drop-down list, select the GCS target that uses SSH. To create a target, add an Oracle Java Cloud Service deployment target. Sixth, To deploy the artifact manually from the type options, select On Demand. And to deploy the artifact automatically, every time the specified jobs build is successful, select Automatic. 7. In Job Build and Artifact, specify the job build and artifact to deploy to the target service. Build isn't available if you selected Automatic as type. 8. If you selected On Demand as type, click Save and Deploy. If you selected Automatic as type, click Save Only. Add an Oracle Java Cloud Service deployment target. To deploy to GCS, you need the credentials of a user with the GAA as administrator or Java Administrator's identity domain role, public IP address of the GCS instance, and the port number of the WebLogic server. You can find the IP address and the port number from the software development environment in the environments page if configured. You can also find the details from overview page of the GCS instance. And here are the steps in adding an Oracle Java Cloud Service deployment target. So we have 9 steps in here. First, on the deployment configuration page, from the new drop-down list of deployment targets, select Java Cloud Service. Next, in the deployment of Java Cloud Service dialog box, select the WebLogic server version and the protocol, Oracle WebLogic RESTful Management Interface or SSH. You can deploy to Oracle WebLogic Server 11G using the Oracle WebLogic RESTful Management Interface. Third, in host, enter the public IP address of the GCS instance. Fourth, in HTTPS port, enter the HTTPS port number of the WebLogic server that runs on the GCS instance. By default, it's 7002. If you selected the SSH protocol in administration port, enter the admin port number of the WebLogic admin server that runs on the GCS instance. By default, it's 9001. In username and password, enter the credentials of the user with the GEES administrator or Java administrators. Identity domain role. Click Find Targets. In the Available Targets dialog box, select the GCS servers or clusters you want to deploy the application to. You can select more than one option. To know more about servers and clusters, see the targeting deployments to servers, clusters, and virtual host topic in Fusion middleware deploying applications to Oracle WebLogic server. 8th, click OK, and lastly, continue filling in the details in the deployment configuration page. Next is deploy an application to Oracle Application Container Cloud Service. DevCS provides tools to build and deploy your Java, Java EE, PHP, and Node.js applications to ACCS. You can deploy the application to the ACCS instance of any identity domain and data center. To deploy your application to ACCS, configure a job to create an archive of the application that includes the application, any dependent libraries, and the manifest.json file. See packaging your application and developing for Oracle Application Container Cloud Service. You can deploy the application, undeploy it, and start and stop the application in the target ACCS instance. Other operations such as scaling up and down of applications can be managed from the ACCS console. And here are the steps in deploying an application to Oracle Application Container Cloud Service. First step, in the navigation bar, click Deployments. Second, click Create Configuration. Third, in Configuration Name, enter a name to identify the deployment configuration. By default, the same name is used by application name. However, you can modify it. Fourth, from the Deployment Target drop-down list, select the target deployment service. And to create a target, see Add an Oracle Application Container Cloud Service deployment target. Fifth, in ACCS properties, select the application type and subscription type. Sixth, to deploy the artifact manually from the type options, select On Demand. To deploy the artifact automatically every time the specified jobs build is successful, select Automatic. Seventh, in Job Build and Artifact, specify the job build and artifact to deploy to the target service. Build isn't available if you selected Automatic as type. Eighth, to override the commands of the manifest file in the artifact zip, select the Include ACCS manifest checkbox. For example, you can override the deployed application's version number at the time of deployment. In ACCS manifest, enter the contents of the manifest file. The field is a code editor component and you can use code editor features. 9. To enter the contents of the deployment descriptor, select the Include ACCS Deployment checkbox and enter the commands in ACCS Deployment. You can also enter commands to override deployed applications containers configuration, such as RAM, at the time of deployment. The field is a code editor component and you can use code editor features. 10th, if you selected on-demand as type, click Save and Deploy. And if you selected automatic as type, click Save. Add an Oracle Application Container Cloud Service Deployment target. To deploy to ACCS, you need credentials of a user with the APAAS administrator or APAAS administrator identity domain role and the identity domain of the target service. If you have an IDCS account of Identity Service ID in the Identity Domain field, the Identity Service ID is displayed in the ACCS Service Details page. And here is the illustration of an ACCS IDCS instance ID. First step, on the deployment configuration page from the new drop-down list of the deployment target, select Application Container Cloud. In the Deploy to Application Container Cloud dialog box in Data Center, select the data center of the target ACCS instance. Third, in Identity Domain, enter the traditional or IDCS identity domain name. Fourth, in username and password, enter the credentials of the user with the APAAS administrator identity domain role. Fifth, click Test Connection. Sixth, after the connection is successful, click Use Connection. And seventh, continue filling in the details in the deployment configuration page. Next, we move forward to deploying an application to Oracle Java Cloud Service SaaS extension. You can deploy your application artifacts to the GCS-SX instance of the current identity domain and the service instance of another data center or identity domain. To prepare your application to deploy to GCS-SX, see Preparing Applications for Oracle Java Cloud Service SaaS extension deployment and using Oracle Java Cloud Service SaaS extension. And here are the steps in deploying an application to Oracle Java Cloud Service SaaS extension. First, in the navigation bar, click Deployments. Second, click Create Configuration. Third, in configuration name, enter a name to identify the deployment configuration, and by default, the same name is used by application name. However, you can modify it. Fourth, from the deployment target drop-down list, select the target deployment service, and to create the target, see Add an Oracle Java Cloud Service SaaS extension deployment target. Fifth, to deploy the artifact manually from the type options, select On Demand. To deploy the artifact automatically every time the specified jobs build is successful, select Automatic. Sixth, in Job Build an Artifact, specify the job build and artifact to deploy to the target service. Build is not available if you selected Automatic as type. Seventh, if you selected On Demand as type, click Save and Deploy. If you selected Automatic as type, click Save. Eighth, see the deployment logs for the status of the deployment. Add an Oracle Java Cloud Service SaaS extension deployment target. To deploy to GCS-SX, you need credentials of a user with a JAAS administrator or Java administrator's identity domain role and identity domain of the service. Here are the steps for adding an Oracle Java Cloud Service SaaS extension deployment target. First, on the deployment configuration page from the new drop-down list of deployment target, select Java Cloud Service SaaS extension. Second, in the deployment to Java Cloud Service SaaS extension dialog box in Data Center, select the data center of the target GCS-SX instance. Third, in identity domain, enter the IDCS identity domain name. Fourth, in username and password, enter the credentials of the user with the GAAS administrator or Java administrator's identity domain role. Fifth, click Find Targets. Sixth, in the Available Targets dialog box, click the GCS-SX instance name. Seventh, continue filling in the details in the deployment configuration page. Next is automatically deploy a build artifact. You can configure a deployment configuration to automatically deploy new version of a build artifact as soon as it becomes available. You can also configure a job to trigger a deployment configuration and deploy artifact as a post-build action. First action and what to do. Configure a deployment configuration to auto-deploy its artifact. So you can configure the deployment configuration to automatically deploy an artifact when you create a configuration or later when you edit the configuration. And here are the steps. Whenever the job of the deployment configuration runs a build, DevCS deploys the specified artifact of the build immediately. Next action, configure a job to trigger a deployment action of a deployment configuration. And how to do it? You can configure a job of a deployment configuration to trigger its deployment actions, such as deploy, start, stop, or undeploy when a build of the job runs. The build is marked as successful if the deployment actions are successful. So this is useful if you want to configure a job to run tests on its deployed artifacts. When you create the job and the deployment configuration, you must use the same name for both. And here are the steps. Now, when a build of the job runs, it automatically triggers the deployment action specified in the deployment configuration. Manage deployment configuration and deployments. After you've created a deployment configuration, you can edit its properties, start and stop the deployment, redeploy an application, view deployment logs, and delete a deployment configuration. And here are the actions and how to do it. If you want to edit a deployment configuration, you need to go on the deployments page in the deployment configuration tile, mouse over settings, and select Edit Configuration. Note that you can change the application name and the deployment target of a deployment configuration. Next action, if you want to start or stop the application, you can start or stop the deployed application and the target service from the deployment configuration. And you don't need to open the target service console to do that. In the deployment configuration tile, mouse over settings and select Start or Stop. Next, if you want to redeploy the application, if you made changes to the source code or the build generated in a new artifact, you can manually redeploy the application to the target service. In the deployment configuration tile, mouse over settings and select Redeploy. You'll be prompted to specify the build and the artifact to deploy. Next is if you want to view deployment logs. You have to select the deployment configuration tile and click the logs link on the right side of the page. And lastly, if you want to delete a deployment configuration, in the deployment configuration tile, mouse over settings and select Delete Configuration. In the Confirm Delete dialog box, select the Also Undeploy checkbox to undeploy the application and click Delete. Next is access a deployed application. To access a deployed application in the deployment configuration tile, click the application name link. Enter your identity domain name and your credentials if you're prompted to do so. You can also access a deployed application from the console of the target service. And here are some ways to get the deployed application's URL. First action, access an application deployed to GCS-SX. And how to do it, here are the steps. Next action is create the application's URL that's deployed to GCS. And here are the steps. And that's all for the Oracle Cloud deployment. And we will show some demonstration on the next videos. Thank you.